Dear students, today we'll see the topic Introduction to Trigonometry. Trigonometry might be a new word for you because we have not studied this topic before, and this year we are going to study two chapters regarding trigonometry. First one is Introduction to Trigonometry and the other one is Application of Trigonometry. So now we'll go through the portion Introduction to Trigonometry. Trigonometry. Trigonometry is a word which came from two Greek words, trignon and metron. Trignon means triangle and metron means measure. And in trigonometry, we'll study the relationship between sides and angles of a given triangle. And one thing we need to keep in our mind that trigonometry is applicable in right angle triangles. In our 10th portion, we are applying trigonometry only in right angled triangles. So here one right angular triangle is given, its sides are given, and one angle that is given as theta. Theta is an unknown value to represent unknown angles, the symbol which we are using to represent unknown angles. And the trigonometric values are this one. We have 6 values: sine theta, cosine theta, tangent theta, cosecant theta, secant theta, and cotangent theta. We can remember it that sine and cosine, tangent and cotangent, secant and cosecant. Using a specific order because for remembering formulas and all it will be easy for us. So just remember this order: sine, cosine, tangent, cosecant, secant, cotangent. And the short form is sin theta, cos theta, tan theta, cosec theta, sec theta, cot theta. We are using the first letters of each values. While considering the right angled triangle, we need to revise one theorem which we have studied already. We are studying this theorem from our 6th standard onwards. The theorem is Pythagoras Theorem. Pythagoras Theorem: in any right angled triangle, the square of hypotenuse nothing but its longest side, that is equal to the sum of square of other two sides. So here one triangle ABC is given. AC is the longest side, so it is the hypotenuse, and AB is considered as height and BC is considered as base. So hypotenuse square is equal to height square plus base square. We'll just go through the proof of this theorem. Here one triangle with blue color shade is given, and to each sides one square is attached. So triangle, the side of triangles A, B and C. The square, first square is A with the side A, second square with the side B, and the third square with the side C. So area of each squares will be A square, B square and C square respectively. So according to Pythagoras theorem, A square plus B square will be equal to C square. We'll just go through one example which is given here. Here to a right angled triangle, 3 squares are attached. So first square is of side 4 units, second one of side 3 units, and third one of side 5 units. So while taking square areas of each squares, we can say that for first square the area will be 4 into 4 16, second one 3 into 3 9, and third one 5 into 5 25. So A square plus B square, that is 16 plus 9 will get 25, which is equal to the third square. Trigonometric ratios. Trigonometric ratios will study the relationship between the given angle and the sides of given triangle. So in that we are considering the sides as hypotenuse, opposite and adjacent. Hypotenuse is nothing but the longest side. So the longest side of a triangle, or the side opposite to the greatest angle, that is 90 degree. The side opposite to 90 degree will be the hypotenuse, that is fixed always. And the opposite and adjacent will change according to the given angle. If the angle is given at Q, here the angle is given at Q, right? So Q, the theta is given at Q. So the side opposite to that will be the opposite side, and the side nearest to that will be the adjacent side. If P is given as the given angle or theta, then the opposite side will be here. To that angle, the opposite side will be here, and the adjacent will come as here. Hypotenuse won't change. So here the angle is given down. So the opposite hypotenuse is always the longer side, and the opposite side will be the side opposite to given angle. Adjacent is the nearest side other than hypotenuse. Here the angle is given on the top, and here it is given as alpha. So the hypotenuse longest side, opposite to that angle, the side will be this one. So this is considered as the opposite side, and the side which is near to that given angle will be adjacent side. So from this we can give the relation as sin theta is equal to opposite by hypotenuse, cos theta equal to adjacent by hypotenuse, tan theta equal to opposite by adjacent, and cosec, sec and cot is nothing but the reciprocals of these angles. So cosec equal to hypotenuse by opposite, sec is equal to hypotenuse by adjacent, cot is equal to adjacent by opposite. Trigonometric relations. Now we will go through the relationship between each trigonometric values. As we have told already, sine and cosec are reciprocals, cos and sec are reciprocals, tan and cot are reciprocal. So reciprocal of a value of reciprocal of x, we will write it as 1 by x, and reciprocal of 5 will write as 1 by 5, right? So here since sine and cosec are reciprocals, we can write sin theta equal to 1 by cosec theta, and cosec theta equal to 1 by sin theta. Cos and sec are reciprocal, so cos theta equal to 1 by sec theta, and sec theta equal to 1 by cos theta. Tan and cot are reciprocal, so tan theta equal to 1 by cot theta, and cot theta equal to 1 by tan theta. We can also write one more relationship, that is tan theta can be written in the form of sine and cos. So tan theta is equal to sine theta by cos theta, and since cot is reciprocal of tan, cot theta equal to cos theta by sine theta. We can remember this formula with using a hexagon method also. So here one hexagon is given. Hexagon, we know that it is a 6-sided polygon, right? So and each corners will write all 6 trigonometric values and write in this pattern, that is sine cosine, tan cotangent, sec cosec. So and now we'll just join the diagonals of that hexagon and write one at the center. So here sine is connected with cosec, cos is connected with sec, and tan is connected with cot. So sin theta can be written in the form of 1 by cosec theta, cos theta can be written in the form of 1 by sec theta, tan theta can be written in the form of 1 by cot theta, and the reverse also. Cosec theta can be written in the form of 1 by sin theta, sec theta can be written in the form of 1 by cos theta, cot theta can be written in the form of 1 by tan theta. Now we will go through trigonometric ratios of some specific angles. So some frequently using angles, that is 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. So here one table is given with each trigonometric ratios, but it's not necessary to by heart the table. We can study how we are forming this table. So here one more table I have given with 0 to 1 in 4 equal parts, that is 0, quarter, half, 3/4 and 1. We will take square root of each value, and that values we can give for the rows where sign is given. So square root of 0 will be 0 itself, square root of 1 by 4 is 1 by 2, square root of 1 by 2 is 1 by root 2, because 2 we don't have a square root, and square root of 3 by 4 will be root 3 by 2, and square root of 1 will be 1 itself. So we completed the sin is column. Next, to write cos A, we can just write it in reverse form. How we have written sin A, just reverse we can give to cos A's column. So 1 root 3 by 2, 1 by root 2, 1 by 2 and 0. Now tan A, to write tan A we can write it as sin A by cos A. So divide sin A by cos A. 0 by 1, 0. 1 by 2 by root 3 by 2. By 2 by 2 will cancel. So 1 by root 3. 1 by root 2 by 1 by root 2. Same value by same value, it will be 1. Root 3 by 2 by 1 by 2. By 2 by 2 will cancel. Root 3 by 1 will become root 3 itself. Now 1 by 0. 1, if denominator 0 comes, we don't have a value for that. So we will write it as not defined, because we know that if we are dividing 6 by 2, 6 by 2 will get 3. That is 3 into 2 will be 6, right? So here 1 divided by 0, if we are writing as 0, 0 into 0 we won't get 1. Same way 1 divided by 0 equal to 1, if we are writing 1 into 0, it won't come as 1. So we won't get a perfect answer for that. So we'll write it as not defined. Wherever denominator 0 comes, we'll write it as not defined. Next, cosec A. Cosec A is nothing but 1 by sin A, just reciprocal of sin A. So 0, reciprocal of 0 is 1 by 0, so which is not defined. Reciprocal of 1 by 2 will be 2. Reciprocal of 1 by root 2 will be root 2 by 1, that is root 2. Reciprocal of root 3 by 2 is 2 by root 3. And reciprocal of 1 is 1 itself. Now for sec A, we can just write the reverse of cosec A. So it will be 1, 2 by root 3, root 2, 2, not defined. Cot A, either we can take it as 1 by tan A, or cot A, it's easy that we will just write reverse of tan A. Not defined, root 3, 1, 1 by root 3, 0. So during our exam time and all, we can just create this table by our own. So it will be easy for you to attend the answers. Trigonometric ratios of complementary angles. Always remember that sine as here sine and cos are connected, tan and cot are connected, and sec and cosec are connected. Sine, cosine, tan, cotangent, sec, cosecant. And the complementary angles, always the value will be equal. Here we'll just go through the formula first. Sine 90 minus a equal to cos a. Cos 90 minus a will be sine a. Tan 90 minus a will be cot a. Cot 90 minus a will be tan a. Sec 90 minus a cosec a. Cosec 90 minus a will be sec a. That is, consider here a is 30 degree. So sine 90 minus 30, that is sine 60, will be equal to cos 30. Or if a is 20 degree, sine 90 minus 20, that is sine 70, will be equal to cos 20. Sine 70 and cos 20, that is sum of two angles is 90. So they are complementary angles, right? So in complementary angles, the values of sine and cos will be equal. Tan and cot will be equal, sec and cosec will be equal. To remember the formula, we will use the same hexagon which we have used already, and consider the straight line to sine to cos, tan to cot, and cosec sec to cosec. So sine and in complementary angles, sine and cos are connected, tan and cot are connected, sec and cosec are connected. So we can write it as sine theta equal to, or sin x equal to cos 90 minus x, and reverse also we can write cos x equal to sin 90 minus x, and for each values. Moving on to trigonometric identities. Trigonometric identities are also some more relationship between trigonometric values. So here we can take the same hexagon to remember this formula, and in hexagon the diagonals are drawn. While drawing the diagonals, you will get 6 equal triangles inside that hexagon. So consider 3 alternative triangles. So that is connecting with the sine and cos one triangle, cot and cosec one triangle, tan and sec one triangle, and put an arrow like this. Now we'll create the formula like this. Sine square a plus cos square a will give 1. From the starting point of arrow, we'll take it as sine square a plus cos square a equal to 1. Same way, tan square a plus 1 equal to sec square a. And one more, 1 plus cot square a equal to cosec square a. So we got the trigonometric identities. These three are the trigonometric identities. From that we can create some more formulas also. So that is sine square a plus cos square a equal to 1. So if we want to find sine square a and cos is given, we can use it as sine square a equal to 1 minus cos square a. Or if we want to find cos square a, we can write it as cos square a equal to 1 minus sine square a. That is, so we are taking one value to the other side of equal to, that is all. Next, tan square a plus 1 equal to sec square a. So 1 can be written as sec square a minus tan square a, and tan square a equal to sec square a minus 1. Same way, 1 plus cot square a equal to cosec square a can be written as cot square a equal to cosec square a minus 1, or 1 equal to cosec square a minus cot square a. Now conversion to sine theta and cos theta, that is, in this chapter we have some proving sums. While proving the sums, it's easy to convert each values to sine and cos and then use the solving methods. So while converting, we can all the trigonometric values, all the 6 trigonometric values, we can write it in the form of sine and cos. So first of all, we will remember the formula sine square theta plus cos square theta equal to 1. Both sine and cos will come under that. Next, tan theta can be written as sine theta by cos theta. Cosec theta equal to 1 by sine theta, sec theta equal to 1 by cos theta, and cot theta equal to cos theta by sine theta. Thank you for watching my video.